Oftentimes, we want to be able to convert from degrees to radians or radians to degrees. And the way in which we do this is we need to know how many radians does it take to go around a full revolution? Well, the full revolution of a circle is its circumference. And the circumference of a circle is equal to 2 times pi times the radius. Well, if we divide the circumference by the radius, we get 2 pi. So we're taking the circumference of the circle because that's the complete arc length. If we took the complete arc length that we had and then we divided it by the radius, because we're comparing the length of those, one full circumference divided by the radius is 2 pi. So a full revolution is 2 pi for our measurement. So 360 degrees is equivalent to 2 pi. That's also saying that pi is equal to 180 degrees. To convert then from degrees to radians, you multiply the degree measure by pi over 180. When you're converting from radians to degrees, you then multiply the radian measure by 180 over pi. We have some examples that you can look at. Coterminal angles are two angles in standard position with the same initial side and same terminal side. Doesn't necessarily mean that they're the same measure, but they start and end at the same place. For instance, I could have angle theta here, or I could have angle alpha here. So they start and end at the same place, but one went a full rotation and then some, whereas the other went just from quadrant 1 to quadrant 2. I could also go reverse. I could say that this angle is coterminal with theta. Let's call this one beta. Because they start and end at the same place, but one was counterclockwise. So two angles in standard position are coterminal if their measures differ by a multiple of 360 or 2 pi. So for the pink to the blue, they both went from quadrant 1 to quadrant 2, but then the blue also went a full 360 degrees more. Arc length is the measure of the distance on the outside of that circle. So it's the portion of the circumference that's created by those two rays. The way in which I find the arc length is when we have this central angle, we can take the radius times theta to get S. Because remember, if you're thinking about theta, theta was S over R, because we were talking about our radian measure. So to find the arc length, you just take the radius times theta. Now to find the area of a sector of a circle, you need to recall the area of a circle formula. So remember that the area of a circle is equal to pi r squared. Remember that a full rotation is 2 pi. If we have theta in radians, then the portion of that circle is theta out of 2 pi. Instead of pi r squared for the full circle, we're only going to take theta over 2 pi of that. That's the portion, and that's the full piece. So this is the full area, and this is the portion we want. And if you simplify that, notice that the pi's cancel, and you have 1/2 of theta r squared. That's how you find the area of a sector of a circle. That's all we have for this section. Stay tuned in our next video. We're going to work through the examples of each of these skill practice questions that you see.